Today I'll talk about causal discovery. This is first lecture in my series of lectures on cause and effect modeling. First I will give introduction followed by description of causal patterns. Then I'll talk about randomized study versus observation study followed by variables under cause and effect studies. Then I'll talk about cause and effect diagrams. Then I'll talk about causal discovery and then I will use various Python packages for causal discovery. Causal modeling and machine learning. Gartner's analytics maturity model is a model that helps companies assess the maturity of their customer retention programs and improve customer retention rates. The model has four phases. So these are basically utilization of machine learning in customer retention programs, and it describes various phases of machine learning. Descriptive analytics analyzes what has happened in the past. Diagnostic analytics uses insights from past data and uses it for decision making. Predictive analytics uses historical data to build models that make predictions. Descriptive analytics chooses the optimal analytics solution to solve the business problem. So now let us see where cause and effect modeling or causal modeling comes in Gartner's analytics maturity. This image I have taken from internet. So it describes the complexity of processes, and these are the headings. So first is descriptive analytics, then diagnostic analytics, then predictive analytics, then prescriptive analytics. And in prescriptive analytics, we have optimization and causal modeling. Causal modeling is related to machine learning. A cause is nothing but an underlying cause, an effect from the cause. An effect may be positive or negative. A positive may be our objective and negative is our problem, depending on the issue that is being discussed. If we understand the causes of accidents, war, and natural disasters, perhaps we can avoid them in the future. If we understand the consequences or effect of our own behavior, perhaps we can modify our behavior in a way that will allow us to lead happier and safer lives. A cause and effect analysis is an attempt to understand why things happen as they do happen. People in many professions spend considerable effort trying to understand the cause and effects of human behavior and natural phenomena to gain better control over events and over ourselves. So ultimate objective is to gain better control, and these are various professions which do cause and effect analysis and causal modeling. Accident investigators, scientists, historians, doctors, newspaper reporters, automobile mechanics, educators, police detectives, to name a few professionals. The cause and effect model help us to think more analytically. The method give us structure to investigate a significant action, situation, condition, or conflict. Through a process of inference, we break down our problem into number of pieces to better understand what we are analyzing. This is done with the help of cause and effect diagrams, which I will describe later. The process guides us through several stages where we can hypothesize causes, effects, prior causes, that is root causes, and after effects, effects of each effect, followed by conclusion and generalization. Causality, correlation, and association are not same. However, with causal research, the correlations of analytical models become causalities. So, causal patterns. There are various types of causal pattern. First one is linear causality, where cause precedes effect. Domino causality, sequential unfolding of effects over time, can be branching where there is more than one effect of a cause. Cyclic causality, one thing impacts other, which in turn impacts the first thing, and it involves feedback loops. Spiraling causality, one thing impacts another, which in turn impacts the first thing with amplification or de-amplification of effects. Relational causality. Two things work in relation to each other to cause an outcome. It often involves two variables in comparison to each other. There may be a relationship of balance, of equivalence, of similarity, or there may be a relationship of difference. Then mutual causality. Two things impact each other. The impact can be positive for both, negative for both, or positive for one and negative for the other. So these are various causal patterns. Then what is the advantage of randomized experiment as compared to observational studies? So let us say there is a simple case to find the effect of a cause. In randomized control experiments, we have a treatment variable and an outcome variable. Treatment variable is nothing but the cause, and outcome variable is nothing but an effect. So in a randomized control experiment, we have two groups, treatment group and control group. In treatment group, we apply treatment. In control group, we do not apply treatment. Then we calculate mean of outcome variable in these two groups. Then the difference in mean of these two groups is nothing but the effect of treatment on an outcome variable. Then there is a concept of confounding variable. A confounding variable is a variable which influences both treatment variable and an outcome variable. So it affects both. So by randomization, we nullify the effect of confounding variables. We distribute the effect of confounding equally among treatment group and control group by randomization. So we distribute the effect of confounding equally between these two groups. So we nullify the effect of confounding variable. Since the observation studies are not as such randomized, there is a need of spatial analysis of such a data. The effect analysis of an observational study involving one or more confounding variable is known as cause and effect modeling. In my next lecture, I will describe how to calculate the effect from an observational study. Then, what are the variables under cause and effect studies? So we have seen a treatment variable, we have seen an outcome variable, we have also seen confounding variable. Now there may be an instrument variable which affect the treatment variable, but it does not affect an outcome variable directly. Then there may be a multi-level causes. Cause 1 is affecting cause 3. Cause 2 is affecting both cause 3 and an outcome variable, whereas cause 3 is affecting cause 4 and cause 4 is affecting an outcome variable. So it is a multi-level causality, and this is analyzed by a Bayesian network analysis. I will be having one full-fledged lecture on Bayesian network analysis. And cause and effect diagrams. What is a cause and effect diagram? It is a graphical tool that helps identify, sort, and display possible causes of a problem or quality characteristic. Constructing a cause and effect diagram can help our team when we need to identify the possible root causes, the basic reasons for a specific effect, problem, or condition, sort out and relate some of the interactions among the factors affecting a particular process or effect, analyze existing problems so that corrective actions can be taken, indicates possible causes of variation in the process, increases knowledge of the process by helping everyone to learn about the factors at work and how they relate, identify areas where data should be collected for further study. These are various types of cause and effect diagrams. First one is fishbone diagram, also known as Ishikawa diagram, herringbone diagram, or Ishikawa diagrams. Then cause and effect tree and Y tree. The cause and effect tree is conceptually similar to the cause and effect diagram as described above. Why do we do tree analysis? When we are focusing on finding a singular cause for a problem and are not concerned with having a visual aid, a Y-tree analysis may be our best option. In a Y-tree cause and effect analysis, we start with the primary cause, then continually seek smaller issues causing it until you find the best problem in need of a solution. Professionals also call this 5 why method. Then another type of cause and effect diagram is Bayesian network. I have taken this from these resources. Then first one is Ishikawa diagram. Dr. Ishikawa, in his Guide to Quality Control 1976, described the Ishikawa diagram. He is a noted Japanese authority on quality and productivity, developed cause and effect diagram for problem solving. There are three types of cause and effect diagram. Cause enumeration diagram, a graphic diagram used to list all the possible causes of a problem. Dispersion analysis diagram, a diagram used to analyze the cause of variability in a process. Process analysis diagram, a flow diagram used to study quality problems. So this is a Ishikawa diagram. We start with an effect, then we identify the headings of various causes. Then, so for example, if the problem is poor mileage of a car, then we give headings to various causes. There may be problem with methods, there may be problem with machinery, there may be problem with materials, there may be problem with people. So these are maybe one or more causes. So causes under methods category is use of wrong gears, driving too fast. Then these are causes under machinery, these are causes under people, these are causes under material. Then we further identify cause of a cause and so on. So this is about Ishikawa diagram. Then this is a causal tree. So we list the headings followed by subheadings. Then the 5 why technique. The 5 why technique was developed in 1930s by Toyota, founder of Toyota Industries, and it is still in use today. The purpose is to identify the root cause of the problem when a process results in an unsatisfactory outcome. Then Bayesian network models mathematically represent the cause and effect reality. It is a reality reduced to influences and areas of interest to us and always associated with uncertainties. Within such network, we can explore reality by applying and varying the mathematical models. In this way, we expand our knowledge space in terms of modeling. So I have full-fledged lecture in Bayesian network analysis. This is an example of Bayesian network. So pollution and smoking causes cancer, and cancer causes alteration in X-ray and causes a symptom of dyspnea. And these are various probabilities associated with it. Then causal discovery. In causal discovery, we will discover various variables which are the important causes and the interactions between these causes in the form of a graphical representation known as DAG or directed acyclic graph. We can draw directed acyclic graph using our past experience, or we can take help of expert to decipher causal relations between variables of our data set. DAG refers to directed acyclic graph, which is a graph with no directed cycles. So there should be no cycles. In graph theory and computer science, a DAG consists of vertices and edges, with each edge directed from one vertex to another, such that following those directions will never form a closed loop. So this is the causal discovery using expert opinion and past experience. Then we can do causal discovery using various algorithms. So this is the mathematical approach. These are various algorithms which we use. The common one are PC algorithm and no-TS algorithm. Then we can classify these mathematical algorithm into constraint-based algorithm, example PC and FCI, score-based algorithm or maximum likelihood score-based GES and CAM, generation network setting, example CGNN and SAM. These are the steps of causal discovery by using various algorithms. So we have a data. Then we, by using graph recovery algorithm, we get undirected graph. Then we, by using causal discovery algorithm, we get directed graphs or DAG. Then about Python codes, I will using various libraries for causal discovery. So this is our data. I have taken this data from internet and this is the heading of the data. Then We drop certain columns, then we make the list of non-numeric columns so that we can label and code the non-numeric columns because uh, the string variables are not understood by our various algorithms. So first of all, package we use is Causal. These are the import of libraries and methods, and this is the code for causal discovery. So as we can see that G1 affects G2 and G2 affects G3. So G1, G2, G3 are grades of students, and these are other variables which affect the grades, including address of student, internet use by the student, absences of the students, and failures and study time similarly. Then this is the same diagram by using the network X library, then causal learn library. So we will use the same data as we have previously. And this is the causal discovery by using the causal learn package. And since it uses the data in the form of numpy array, so we have the labels as different here, and the labels corresponds to these uh, our column headings. Then package CDT. So this package CDT will require R to be installed in our system, and this is the location of R script. And so these are import of various libraries and methods. And the same data we will use here. We will use PC algorithm, and this is our causal discovery graph using network X. Then this is the PGMPY package. We will use the same data and we will use PC algorithm. And we have identified these five edges here. Then we will use the package causality. These are the import of various libraries. We will use same data. And we will use here as IC algorithm. So this is our causal discovery. So this is all for today. Thank you very much.